Hi everybody, welcome back once again to this channel. Thank you very much for joining us once again. We are still continuing with some revision of your trial exam paper. Someone commented on some session to say, can you please do question 5 from the Northwest Province? Okay, so here's your question 5. It's on coming from your trial exam. So if you're new to the channel, guys, please make sure you subscribe. Just turn on that notification bell so that you can be notified every time when we upload a new session. Without wasting any time, let's get into it. Okay, so this is your question 5. It says in the diagram below, the graphs of f of x equals to a sine 2x and g of x equals to tan b of x are drawn for x element of minus 90 to 90. We have p, which is negative 68.53 and negative 0.68, and q are point of intersection of f and g, and we can see the p and q are actually points of intersection. So the first question, 5.1.1, it says find the value of a. It's only for 1 mark, right? So if you check A is the amplitude of the sine graph. Obviously, you'll say half the maximum, half the distance from maximum to minimum, right? So you can see the half distance from 1 to minus 1 is 2, but half distance of that amplitude is 1, right? So obviously A equals to 1. Okay, so 5.1.2, calculate the coordinates of Q. It's 2 marks, guys. So obviously you don't have to show the workings and all that, right? Obviously Q, I know most of you might think of, okay, it's the point of intersection, I just equate the two graphs, but the problem is that we don't have B there. Okay, we don't have B, and there's a question that wants B somewhere, meaning that will not work for us at that point, right? So to get Q, actually it's symmetrical to P, right? It's basically symmetrical to that because this is a tan function. So basically Q will be this answer, but it will be positive because it's on the positive side, right? So Q will be positive 68.53 and 0.68. Okay, so because it's like symmetrical, this is a sine function, and you can see that is minus 68.53, and probably there it's like symmetrical to that should be 68, the positive 1.53, right? Hence you just take that one, you change the sign for Q. Okay, so for 5.1.3, they said write down the values of x of the turning point of h if h of x equals to f of x plus 30 degrees. Okay, what is happening? H is a new graph that is gotten by shifting the graph of f. Can you see? If we are adding 30 degrees, how can you know how was shifted? You can say x plus 30 equals to 0. You say x equals to negative 30 degrees. Then you'll know that the graph was shifted 30 degrees to the left because your answer there is negative. Okay, so 30 degrees to the left, what does it mean? It means, well, there is a turning point. You understand? The turning point there is 45 degrees and 1, and this side is negative 45 degrees and minus 1. What you do on the turning point, you are shifting it 30 degrees to the left. So in other words, you have to minus 30 degrees. So a common mistake is that you'll find, because they say x plus 30, people come and add 30, which is wrong, right? So basically you must first check how was it shifted. It's 30 degrees to the left. It means you are moving it to the left. It means that x value is decreasing by 30. So it will be 45 degrees minus 30, and 1 will remain 1, and another turning point minus 45 degrees minus 30, and minus 1 remains 1. Then obviously the answer there will be 15 degrees and 1, as well as negative 75 degrees and minus 1 as your turning points. Okay. Okay, 5.1.4, it says values of x where g of x is between negative 0.68 and less or equals to 1. All right, let me just use a different color to highlight this. Between negative 0.68 So you'd understand that this side will be negative 0.68 and between 1 where G is between that. So between 1 it's there on top, right? Because I'm looking for G. So this is 1. Okay, so they are saying what are the values of x. So let's check the corresponding values of x here. The value of x, we know that point is negative 68.58, 0.53 and negative 0.68. So the x there is minus 68.53 degrees, right? Then we check the x there, it's what? It's 90 degrees, where G is actually between that interval, right? That is between 0.68, negative 0.68 and 1. The x values, we can see it's 90 degrees as well as what? As well as minus 68.53. So the values of x, it's when x is greater than minus 68.53, right? We're saying when x is bigger than this, we are going like this up until when x is equals to what? Is less or equals to 90 degrees, because there's a less or equals to 1, so less or equals to 90 degrees. Okay, let's quickly go to 5.1.5 now. Okay, 5.1.5, it says find the value of m where f of x plus m will actually be equals to minus cos 2x, right? Where f of x plus m is equals to minus cos 2x. What is f of x? Our f of x, if we replace our a, which is 1, it will just be sine 2x, right? But they're saying where f of x plus m, you understand, where it is equals to negative cos 2x, right? So if I write this, it will be sine of 2 into x plus m. This is now f of x plus m, where this sine of 2 into x plus m will basically be equals to negative cos of 2x, right? But it just has 2 marks. It means we don't have to go and solve this, right? You can if you want, but I think it will take a lot of time to do that. Basically what you can do, you can go and draw the graph of cos 2x, right? So basically cos 2x will start probably from 1, right? The positive 1 will start there from 1. Let me see, this pen is disappointing. It will start from 1 like that, you understand, going down, because at cos 2 times 45 it will be 0, so it will come and cut here. Let's see. So but that's the positive 1, right? Rather we must draw the negative 1, which will move like this, as it reaches 90. Cos 2 times 90, this will give us negative 1, so it will be like, it will move like this, yes, see, and then this side it will move like this, so this is the graph of what? Of minus cos 2x, right? And you just check to say how can we shift. You understand what's happening here is that we are shifting the graph of f by m units, right? Either to the left or to the right. How can we shift it such that it can be the same as this red graph? How can you shift this one? Let me indicate it with orange, because this is the one for sine, such that at the end it can just be equals to the reflection of the cos 1, right? The negative cos 2x. Okay, so the idea is that how can I shift this one? Can you see this one? Such that it's now the same as this one, like it goes this point from there, it moves there. Can you see? I have to be shifting the sine 1, sine 2x to the what? To the right. so that it can come to this point where the cos 2x is. Can you see? So if you check the difference there, it's like 45 degrees, right? But we have to be shifting it 45 degrees to the what? To the right. Can you see? So 45 degrees to the right, it means that m must be equals to negative 45. Okay, so yeah, m must be equals to, okay, if it's negative, it will mean we shifted it to the left. M must be positive 45 because we are shifting it to the right. Okay, so this must be our value of m basically. Okay, so because let's check first. I might be wrong. If I say fx minus, if I say m is positive, it will mean when I solve here, it will mean, you know, I'm shifting 45 to the left. Okay, can you see the mistake here? So it means that when you substitute m there, it must be negative, so that, you know, when you equate to 0, it shows that, okay, you've shifted it plus 45, that is to the right. So m must be negative 45. Okay, so that is the value of m, that graph can be the same as that. So basically shifting that so that, you know, shifting this one so that it's now there on the red. So you can see from minus 90 to minus 45. So you understand how to do this by redrawing the other one and going and see how you can shift it such that it can be in the same position as the other one. Okay, let's go to 5.1.6. Okay, so 5.1.6, it says find the value of b. You can check the mark is only one mark. You just need to give the value, right? If you check b, it's on tan here, right? On the graph saying g of x equals to tan bx. So b would actually be found by saying the period of a tan graph, right? The period divided by I'm saying, okay, I think I made a mistake a bit. So we are saying the period of this graph of tan will be 180 degrees divided by b. Okay, so basically that's how you'd find it. So the period, it's like when does the graph complete its full wave. So you can see the graph of tan from this portion, first portion, second portion. So 90 degrees and 90 degrees. So it completes its full wave after 180 degrees, and you can see here it's 180, right? Because this portion is 90 and this other one is 90. Okay, so the period is 180. Then you can see it's just the normal tan, so b will be equals to 1. Okay, you don't even have to solve, you just have to observe to say, okay, when does it complete its full wave? This is the half of the wave, second of the wave. So it's 90 and 90, so it's the normal tan x graph, right? So it's tan x, meaning that b is 1. Okay, let's move to the last question now. So if you check the last question, it's saying 5.2, for which values of values of x in the given interval will x times the root of g of x minus f of x be greater than 0? Okay, so don't be intimidated with this. G of x minus f of x. Basically, this means where the other graph is on top, the other one is below, right? But the fact that the square root here, this is like distance between the two graphs, the g and f, the vertical distance between them, right? It's like the vertical distance between g and f. Can you see? It's like this is your g, this is your f. When they say g of x minus f of x, right? So obviously distance will always be positive. It means that inside the root it will always be positive. Obviously also for us not to get error, right? That must always be positive. So the only key thing here, because this will always be positive, right? So it means that to ensure that this is always greater, x will be the one determining, right? So if x is negative, this one is root of positive, it will give you a negative answer which is less than 0, right? So x is the determiner here. So if x is positive, then this is always positive, there's no root of a negative, right? So this is always positive, then positive and positive will always be greater than 0. So in other words, they are asking you where x is greater than 0. Do you understand? For g of x and f of x, where x is actually greater than 0. Okay, so we have to check where x is greater than 0. Obviously, where you find g and f. So you can see that from this point, x is greater than 0 going there. It's where, you know, you have your f, you have over g. So the graph will always be positive there for all values of x greater than 0 degrees. Okay, so you just say x greater than 0 degrees, right? Because if we go to where x is negative, you know, the graphs will basically, this x is negative affects, it won't be greater than 0, right? So basically it's when x is greater than 0. Okay, because this must be positive. So basically they're asking you where this is positive. So where x is positive, obviously just when x is greater than 0. Okay, so I hope you find this helpful. Don't forget to like, share, comment, and subscribe. See you soon. Bye.